Okay, so I got my notation all confused. I put x's in here, had x's and y's and t's because I originally wrote it as partial with respect to x. And anyhow, okay, so we have this function, okay? And we want to write this in this form. Well, we can't because we don't have x's. There's the form of an exact equation. But if your variable, your independent variable is not x, then you got to use whatever the independent variable is, which is t in this case, just implicitly from the equation, a function of t. Okay? So you got y dy dt is 3t squared plus 3t squared minus 2 equals 0. Just writing the y prime as dy dt. Now I say always, you can't really multiply through by dt, but you can get away with it here. That's not really what's going on, but this rearranges to this in any case. Okay? And it's as if you'd multiplied by dt. So we have this, which means that the equation is in this form, where m is what's in front of the dt. That's the 3t squared minus 2. And n is what's in front of the dy, and that's y. So now we take the y derivative of m. Well, 3t squared minus 2 doesn't have any y in it. So it's a constant with respect to y. Okay? And the derivative of a constant is 0. In other words, this isn't changing with respect to y. If y changes, this doesn't do anything. So its y derivative is 0, right? Here, n is y, and the t derivative of y is 0. If t changes, y doesn't change. Okay? If there's no change, then the rate of change is 0, the derivative is 0. So, informally, just treating y as a constant, that's another symbol, and taking the derivative with respect to t, we get 0. Okay, well, this tells us that m is a partial of f with respect to t, and n is a partial of f with respect to y. We want to find f. Find our function f of xy. Because then our solution will be f of xy equals constant, as we saw before and as we get used to in practice. Okay? And check. Okay, good. Now, so if m equals partial of f with respect to t, well, we can write that out. We can then say, okay, partial of f with respect to t equals t squared minus 2. Okay, so f is 3t squared minus 2, integral 3t squared minus 2, which is t squared, t cubed. It's not a great looking 3, but that's what I can do with the chalk right now. Okay? 3t minus 2 plus an integration constant. Now your integration constant can actually be a function of y because y is constant with respect to t. Any function of y is unchanging when t changes. So we can say that this is a function g of y. And we can check this. Okay? If this is your antiderivative, then the derivative of this had better equal 3t squared minus 2. Well, derivative of t cubed is 3t squared, derivative of 2 is negative 2t is negative 2, and the derivative of g of y is 0. So that works just fine. And we're probably going to need that g of y. Okay, because when we do partial of f with respect to y equals y, because, of course, n is partial of f with respect to y, and n is what's in front of dy, and it's in front of dy, which is the y. Okay? y squared over 2 plus an integration constant. Well, again, any function of x is an integration constant, is a constant with respect to y, so we can use any function of x as our integration constant. Okay? So, we can conclude that t squared minus 2 plus g of y equals y squared over 2 plus h of x. Well, from that, we can conclude what g of y has to be, and we can conclude what h of x has to be. What do you think g of y had better be?
Y squared over 2.
Yeah. Yeah. I mean, if this is equal to this has to have a y squared over 2 in it. Well, that is a function of y, so that's your integration function. So we have t cubed minus 2t plus y squared over 2.
I want one.
Okay.
I really do.
And over here, what's h of x? And it's not h of x, h of t. And that's h of t. Keep wanting to put x in there. I guess I got up too early this morning. Not that early. Not a big excuse, but anyhow, okay, so what's h of t?
It would be t cubed minus 2t.
Yeah. So y squared over 2 plus t cubed minus 2t, and we get that by letting h of t equal t cubed minus 2t. So now, f of ty equals t cubed minus 2y plus y squared over 2. The solution to our equation is t cubed minus 2t plus y squared over 2 equals 0. And we solve this for y. Okay, well, easy to solve that for y. I'm not going to have you do that. You just move everything over there and all that stuff. Y is going to end up as plus or minus the square root of 4t minus 2t cubed. Okay? If I did that correctly. And your domain is going to have to be restricted here because, of course, 4t minus 2t cubed, for most values of t would be negative. If t is small enough, t cubed is smaller than t, and all that stuff, then you can figure out what the domain has to be. It's going to run from negative square root of 2 to square root of 2. Okay? And I'm wrong about that. Because if t is a large negative number, that works. So it's like infinity to square root of 2, I think. Okay? Anyhow, you can figure that out. By solving the inequality. T minus 2t cubed is greater than or equal to 0. Okay? Which translates to t times 4 minus 2t squared greater than or equal to 0. Okay? Now that's true if t and 4 minus 2t squared have the same sign. So if both t and 4 minus 2t cubed, 2t squared are negative, that's in your domain. And if they're both positive, that's in your domain. So you've got to work that out. So you want to think that through. Okay? And then you can check the solution. Okay? Y times y prime, well, you got a chain rule and stuff, and then 3t squared minus 2 and all that. Okay? And it all has to add up to 0. So the algebra, that derivative and stuff, it's worth going back and checking to make sure we did it right. And since I did it right, if it isn't right, it's on me. And if it isn't right, you can fix it. Okay?
Okay.
But that's the process. Not overly difficult, but it's real important to understand why you're doing what you're doing. The whole thing goes back to m being a partial with respect to whatever this variable is, n being a partial with respect to whatever this variable is, of the same source function. If you just set that source function equal to 0, and you get your solution.